Show captions. Good morning, everyone. This is Shauna coming to you with a special video today. It has come to my attention that most of you are pretty well bogged down in section 3.2 with the homework. So I'm hoping that this video should help that. There are at least 2 videos right now dedicated to specific problems, one to number 4, which is an ungrouped data problem, finding the standard deviation and the variance. And the other one is a Chebyshev's problem from later on in the homework. But in this video, what I'm going to do is go through the slides with you and show you which slides relate to which problems, and maybe hit on a couple of highlights from some of the problems. And hopefully that should help you get unstuck with your difficulties, whatever they are. Okay, so let's continue. Let's go on with this. So here is the homework assignment. Okay, this is the homework assignment. The first 3 are comprehension questions that are designed to show us that you've been reading the slides and or the book. There is no computation in these. We're just making sure that you understand concepts, because you need these concepts for the problems later. So the first question is, what is the relationship between the variance and the standard deviation? What are the symbols used to represent the population variance and the population standard deviation? And why is an unbiased estimator of variance used? Okay, so let's look at the slides. If you're not reading the slides while you're doing the homework, you're doing yourself a disservice. You need to be reading the slides because a lot of content comes from there. So let's pick up, this is the, let me make sure that I'm screen sharing properly here. Okay. I believe you should be seeing the slides now. Yes, I believe so. So if you look on the second slide, or actually the third slide here, the second content slide, it gives you the definition of the standard deviation, and it tells you what the symbols are. Okay, so the symbol for the population standard deviation is this thing that looks like an O with a line over it. That's called sigma. Okay, and the symbol for sample standard deviation is S. So that's the symbols. That's question 2. All right, now let's go on to the next part of this. So on the next slide, you're given the formula here. Okay, you're asked to use this formula in some of the computations that come later. But if you look carefully, the variance here is S squared. The standard deviation is S. So the relationship between the standard deviation and the variance is that if it isn't clear to you from looking at it, you can say that the relationship between the standard deviation and the variance is that the variance is the standard deviation squared, or that the square root of the variance, square root of the variance is the standard deviation. Okay, so you can write that in words as I just have done on the screen for you. There's the content. Or you can write this. You can say S, which is the standard deviation, is the square root of S squared. Okay. S squared. All right. So that is the relationship between the standard deviation and the variance. Okay. So let's continue now with the unbiased estimator, because none of you have asked me about that, but it might be on your minds. So let me continue with that now. Whoops, excuse me. Let me, not time for that yet. Let's go back to this. Hold on. What I'm seeing on my screen is not what you guys are seeing in the screen share. So let me fix that. All right. So here's our PowerPoint back. Now here, here's an example of how to calculate it, which goes into number 4. All right. Now, the unbiased estimator is not on here. So if you're looking for the unbiased estimator, that's in the textbook. Let me bring up the text for you so I can show you where that's at, because that isn't in the slides that I'm aware of. If you do find it, please let me know. Let's see, elementary statistics. And let me pull up the book. All right. So let's see. Give me a moment to locate the section and the portion of the book that gives us this, because this is, you're going to find it in 3.2. So let me come to 3.2. And let me look for the unbiased. Let me see. Control F. Unbiased. Okay, so if we look at the text, let me share screen here. And let me enlarge this a bit. It says, when computing the variance for a sample, one might expect the following expression to be used. And it gives you an expression, tells you what the symbols stand for, but it says this. However, in the italics here, it says, let me, like I said, let me enlarge this a bit so that, okay, it says, however, in most cases, the purpose of calculating the statistic, the purpose is to estimate the corresponding parameter, okay? This expression does not give the best estimate of the population mean, okay? So the population variance doesn't work well either, because when the population is large and the sample is small, the variance usually underestimates the population variance. So the reason we use an unbiased estimator is so that we can get a better approximation of the population variance. Okay. Because when the population is large and the sample is small, the variance will underestimate it. So having that that extra symbol in there, that n-1, will help us with that. So if you want to answer the question of, if you want to answer the question here of why do we use an unbiased estimator, it's because I would say this. Let me get my annotation. Okay. I would say the unbiased estimator is used because without it, the formula underestimates, makes it too small, underestimates the value of the variance. So it's to help us get a better estimation of what the variance actually is. And that's what we're trying to do. So that's what I would write for that particular problem. The unbiased estimator is used because without it, the formula underestimates the value of the variance. Okay. Question 4, we get question 4, and for the next few goes into basically your formulas, your data analysis. Okay. So question 4, there's a dedicated video on it. So if you got stuck doing question 4, find the dedicated video that is related to this. But question 4 and question 5 are both ungrouped data. Okay. Question 4 and 5 are ungrouped data, so they're similar. All right. Now, the thing about question 5, there's an extra piece to question 5. I'm not going to work out the range, the variance, the standard deviation, because it's just like question 4. Which set of data is more variable? For that, you're going to go to the covariance formula. Okay. So you're going to go to the slides. Okay. And here you're going to, after she goes through this, on slide 13. All right. Covariance is the standard deviation divided by X bar, which is the sample mean, times 100. So what you would do is you would look at, if you go back to homework here. Okay. Okay, so after you find there's a men's sample and there's a women's sample, right? The top row is men, the bottom row is women. Okay. The way this works is that you treat the men as one sample, you find the mean and the standard deviation for the men, you find the mean and the standard deviation for the women. Then you find the covariance, and whichever one is greater has more variability. Okay, but that's where it comes from. Now, question 6. I had somebody question question 6 because it's a little bit odd, but again, it's on a specific slide. So let me scroll up here so you can read them. Now, question 6 is it says, the average age of US astronaut candidates in the past has been 34. So that's the mean in the past. But candidates have ranged in age from 26 to 46. Use the range rule of thumb to estimate the standard deviation of the applicant's ages. Okay, so the applicant's ages here. So if you look at the slides again, it tells you what the range rule of thumb is. So let's go here and let's look at the range rule of thumb. The range rule of thumb is pretty straightforward. Let me come back because I think it was given to you on one of the slides. I'm just not sure which one it is. Here it is. Oh, that's not it. Sorry, my apologies. This is empirical rule. Gabisha, I thought she gave it to you. But the range rule of thumb says that we talked about that. The range rule of thumb says, and I'll show you in the book where this is, because you can go and look at it there. And then I'll do this one, I will do for you here. So let's look at this. Here's your variance, your standard deviation. Okay. After the formulas for the standard deviation and the variance, we have some other verbiage around here. And the range rule of thumb is after the covariance. So it's tucked away in this little box. It says the range can be used to approximate standard deviation. The approximation is called the range rule of thumb. A rough estimate of the standard deviation is the range divided by 4. So all you want to do for number 6, actually, when she's asking you about the range rule of thumb, all you want to do in this homework is you want to say, okay, well, what is my range? If you remember, the range is the maximum minus the minimum. So you look at the range that it gives you. It says it goes from 26 to 46. So you're going to say that the standard deviation S, let me write this on the screen. The standard deviation S is equal to the range divided by 4. Now, what is the range? Well, the range, the highest is 46. So we're going to say it's going to be, if you're doing this with a calculator, don't forget to use your parentheses. 46 minus 26, that's our range. And we're going to divide that by 4. So 46 minus 26 is 20. So this is 20 divided by 4, and the approximation is 5. Okay, so S, the standard deviation, is approximately 5. And that's all you have to do. That's it. Now, if some of you had a problem with number 7, okay, there could be a couple of reasons. If you downloaded this before it was fixed, okay, there were only 9 values in here, and there should be 12. This version has 12. So you want to find the range, the variance, and the standard deviation for your data. All right. So this is this is giving you that opportunity. There's 12 of them here. I did this problem. This is exactly like number 4, except that it's fewer data. So if you need help with that, you can go back to the video on number 4, but make sure that you've got the version that you see on the screen. So Texas is 355. Virginia is 94. Alabama is 34. Oklahoma is 79. Louisiana 27. Missouri 66. North Carolina 39. Georgia 39 as well. Arkansas 27. Arizona 22. Florida 60. And South Carolina 35. So you can put those data in your calculator, just like number 4. Do it with the formula as I've shown you. So basically 7 and 8, okay, follow number 4. It's the same. Calculate the range, the variance, standard deviation. They follow number 4. So if you're having trouble with that, they follow those elements. So here, let me scroll down. Those are ungrouped data sets, okay? And the way I know that they're ungrouped data is that they're lists of numbers, all right? So that's how that works. Now, let me continue. Let me take this off the board. All right. The number 8 is the same. All right. The number of precipitation days, find the range, the variance, the standard deviation. Again, just like number 4. All right. When you get to number 9, I don't have a dedicated video for, but I will put one up. I will do number 9 for you right here. Now she wants you to do, if it's a grouped distribution like this, she wants you to do this slightly differently and with the calculator rather than by hand with the formula. So let me show you that first. So here, I'm going to put up the slides again. Okay. So if you look at group data, okay, sample standard deviation group data, enter the midpoints XM into L1, enter the frequencies F into L2, press stat to get the menu, press the arrow to the cursor, 1 var stats, and choose SX. So here she gives you an example, all right? The example that she gives you has class boundaries or class limits, it doesn't matter, and the frequency, all right? You need to add in the midpoint column, and then you go to your calculator and you do the procedures. Okay, so we're going to do that now for one of the problems on here. So if you go to number 9 and number 10 and 10 and 11 and 12 will be similar, okay? So all of those are group data. 9, 10, 11, and 12 will all be similar. What I need is the midpoints, okay? So the way you get midpoints, let me share the whiteboard and put this up on the screen. So this is going to be number 9. So here's my selection screen. Okay, So this is number 9 on section 3.2. All right. So we've got 2 columns of data. Let me pull up my page here. So I've got 13 through 19. I've got 20 to 26. I've got 27 to 33. I've got 34 to 40. 41 to 47. 48 to 54. And 55 to 61. And 62 to 68. Okay, those are my class limit. Okay, so these are my class limits. These are given. Now I also have a frequency column. So I'm gonna write in my frequency column next. Now, this is gonna be, let's see, we've got 2, 7, 12, 5, 6, 1, 0, and 2. All right. There's my frequency column. Now, the column that you need to add is midpoint. So I'm going to add midpoint there. Now, if you remember from the previous section, the way you get midpoints is you take either the class limits or the class boundaries, add the upper and lower, and then divide by 2. So it looks like this. 13 plus 19. Put parenthesis around your sum and divide by 2. That comes out to 16. 13 plus 19 is 32, divided by 2 is 16, okay? Similarly, we continue. So we get 20 plus 26 divided by 2. This is 23, okay? If you need help putting it in, I can show you that in a minute. Let me just finish this. This is 23, okay? So what I'm doing here is I'm doing this. So let me come here and show you. On your calculator, if you're having problems entering it, you're going to take 13 plus 19, divide that by 2. That's 16. You're going to take 20 plus 26, divide that by 2, you get 23. You're going to continue on that same idea. 27 plus 33 divided by 2. 30. Okay. And so on. All right. So that's okay. 34 plus 40 divided by 2. There's 7. 41. Oops. That's not what I needed. 41 plus 47 divided by 2. 44. 48 plus 54 48 plus 54 divided by 2. 51. 55 plus 61 divided by 2. And 62 plus 68 divided by 2 gives you 65. Now, I'm going to come back and fill in those numbers on my frequency distribution. Oops. My apologies. New share whiteboard. Okay. So let me stop sharing and go to the whiteboard here. All right. So basically, I'm going to write in what I continued with. I showed you all of that on the calculator just now. So I'm going to continue to fill this in. All right. This is 27. This is 27 plus 32 divided by 2. This is equal to 30. And then we have 33, well, 34 rather, sorry. And this is 33, not 32. So it's 33. This is 34 plus 40 divided by 2. This is equal to 37. Okay. Then you have the next part, 41 plus 47 divided by 2. That's equal to 44. This is 44. Then we have 48 plus 54 divided by 2. 48 plus 54 divided by 2. That's equal to 51. 55 plus 61 divided by 2 is 58. And one more, we have 62 plus 68 divided by 2, and that's equal to 65. All right. What we're going to do now is we're going to go in our calculator and we're going to put the midpoints in one column that we just calculated and the frequency in another column. So I'm going to show you that in the slides one more time. She said to put the, let me roll back one slide here. Two slides actually. On slide number 9, enter the midpoints into L1, enter the frequencies into L2, then do your stuff with the calculator. So midpoints in L1, frequency in L2. So here I have, we're going to take the midpoints. These are going to go in list 1 on your calculator. This is list 1. And the frequency is going to be in L2. Okay. So it looks reversed from what you see on the screen. So the way that looks is this. Let me share the calculator at this time. Let me stop sharing this and share the calculator with you. So we're going to continue with what we're doing here. If you remember, that we did something similar before, okay? We're going to go to stat. We're going to go to edit first. So you need to put the data in your calculator first. I already have data here. If you already have data there, what you should do is a couple of things you can do. If you have multiple lists like this, you can either go up to the list name, up arrow there, and hit clear, enter, or you can also use it, especially this works well if you have a lot of lists. I only had 2, but you can also use second, then memory, which is on top of the plus sign, second memory, and go to number 4, clear all lists. We'll say done, and it will clear all your lists for you at one time. Okay, so either clear enter from the list name individually, or second memory, clear all lists, number 4, enter to clear everything at once. But in this case, let's go to what we need. So I'm just going to put the midpoints in L1, 16, 23, 30, 37, 44, 51, 58, 65. That's my midpoints. And to get my frequencies, I have 2. I have a 7, 12, 5, 6, 1, 0, and 2. So there they are. Now, from here, she doesn't want you to use the formula. All you're going to do is go stat, calc, and even though you have 2 lists, you're going to hit one variable statistics, okay? One variable statistics here, number 1, or hit enter. Now, your list is where your midpoints are, okay? That your list is in L1. This is it. L1 is usually the default, okay? But you can change this if your X's are in a different list. Your X list is in L1. Here, where for ungrouped data, we don't have a frequency list. For a group data, we have a frequency list. This is group data. We have a frequency list. Where are they? They're in L2. So I'm going to say L2. How do I get L2? It's on top of the number 2. So let me remind you here in case you haven't seen this yet. There are blue, or in my case, they're blue. If your faceplate is a different color, they may be orange or red or some other color. But for me, they're blue here. This L2 means list 2. It's on top of 2. If I want to get that, I hit the second key. Second, there. So what I'm going to do is I'm going to hit second L2 like this. And it's going to do that crazy formula for me. Now, just as a refresher, if some of you are not too comfortable with this yet, this list, this thing is going to show you more stuff. So this top line is your mean here, which we don't need for this calculation. When you're doing ungrouped data, you need X, you need X squared. We need SX. That's what she asked us to find. SX, remember, is your standard deviation. Our standard deviation is this number here, 11.55752874. She rounds it to one decimal place, one place after the decimal. So this 5 that's in the second place, the hundredths place, right? Makes this first 5 that's in the 10th place, makes it a 6. So SX is 11.6. Now, to get the variance, we saw before that the variance is just the standard deviation squared. So if I take, let me do something here. Let me write the standard deviation down on the screen. S is equal to 11.55752874. Okay. So here's my S now. That's my S. Now what I want to do is I want to square it. So what I'm going to do here is I'm going to say 11 point, oops, as soon as I get my mouse back. Okay. So I'm going to say 11 point, and I'm going to use that number that I have in the corner. Okay. 11.5575 2874. I don't know what I did there, but you do. 11.5575 2874. All right, there we go. And I'm going to square it. Now, I've been showing you the squared key under square root. I'm going to use the caret this time, the little triangle that doesn't have a bottom. You have the caret up there, you put a 2 there. You square it, you put it in, and there it is. It's 133.57. If I round this, this is 133.6. So your answer for, let's go back. This is my S squared now. Okay, this is my variance. So this standard deviation in black that you see off in gray, this 11.55, we're going to call this 11.6. So we're going to say that that by the calculator work that we just did, we're going to say that S, and remember that's our standard deviation, that's 11.6. And if I square it, I get the variance, and that's equal to so S squared was 133.6. And that's all you have to do for number 9. Okay, just if it's group data, okay, if it's group data, you don't have to use the big formula. If it's ungrouped data, then you want to show all of the calculations, all right? So that's it for number 9. Now, let me just show you a couple of more things here because I don't want to go on too long. So 10 will be very similar. Find the midpoints and then get the frequency and repeat what we did on number 9, just different numbers. Number 11, same thing, find the midpoints, do the calculator. 12, same thing, all right? Even though these are boundaries, okay, you still can find the midpoints by adding these up and dividing by 2, all right? Now, 13 uses the covariation formula, okay? Which 13 and 14 use the covariation formula here. So remember that's your standard deviation divided by your mean. So if I look at 13, I'll do 13 here, okay? It says the average number of days that construction workers miss per year is 11. The standard deviation is 2.3. The average number of days that factory workers miss per year is 8, with a standard deviation of 1.8. Which class is more variable in terms of days missed? Once again, let me come back to the slides. The slides are your friends, folks. So you're looking here at covariation. So now, coefficient of variation right here, okay? So in this case, we're comparing factory workers to construction workers in terms of missed work. So we're going to take the standard deviation divided by X bar is the mean. We're going to multiply it by 100%. That's all we have to do. And then we state which one is more variable. So that's slide number 13. So I'm going to go back to the homework here. And we'll do a calculation, right? So it says that I'm going to take a note here and then I'll put it on the whiteboard. So for construction workers, we have the average number of days. Average is another name for the mean. So be aware of that. That's going to come up handy. So the mean is 11. And the standard deviation S is 2.3. Okay. The average number for the factory workers is 8. So this is our factory workers. And our S is 1.8. So again, one more time. Let's look at this. So here's my formula. S divided by X bar times 100. So this is what we're going to do. This is number okay, all right. This is going to be number 13. 13 on our data. So this is, we have construction workers, and we have factory workers, okay? Now, the construction workers, their X bar, let me draw this. Their X bar was, according to the problem, was 11. And your S was 2.3. Okay, so this is 2.3 here. So this is 2.3. That looks like 2,3, but let's use the theory of a large decimal point right there. All right, now the factory worker, their X bar is 8. Their mean is 8. And their standard deviation is 1.8. Okay, so 1.8. All right. So now let's use our formula. For each one, we're going to calculate 2 percentages here, and we're going to see which one of these is more variable. So we have our data. We're going to take our standard deviation and divide by our mean. Multiply that by 100. So you're going to take the standard deviation for our, so I'm going to write C var is equal to S divided by, and here I need to write it in because Zoom doesn't let me use the notation very easily. So it's S divided by X bar times 100%. So this is 100% here. So then this is 100%. So that's our formula. Now let's do this for each one of these. So C var for the construction workers will be 2.3 divided by, 2.3 divided by 11 times 100%, okay? And 100, let me move that, okay. Let me write it as the dot, that'll probably be better. Times 100%. And for our factory workers, same thing. C var will be 1.8 divided by 8 times 100%. Now you're going to do those calculations and see which one is more variable. So okay, so we're going to, one more time, we're going to go to the calculator. Your calculator in this class is your friend, okay? So for the construction workers, we have following. 2.3 divided by 11 gives us this. We multiply that by 100. This gives me approximately 20.91% for the construction work. And if you take the next group, I didn't mean to multiply that by 100 again, just ignore that. I hit the wrong key. What you should be using is the 20.91 above it. So then for the factory workers, we get your 1.8 divided by 8. Oops. Divided by 8. That's 0.225. We multiply that by 100. And yes, you can do this all in one step. I just want you to see this is 22.5%. So we can see that if we go back to our screen, let's go back to the whiteboard one more time here. This came out, this calculation on the left comes out to CVAR is equal to 20.91%. And this calculation comes out to 22.5% approximately. So which one is more variable? Well, the factory workers. So how would I answer it? I would say the factory workers have more variability. Okay. Don't forget to answer those questions if you have them in the problem. If you just calculate the covariance and you don't answer any question that might be out there, that's an automatic point deduction on the test or the quiz. So don't forget to actually answer the question. But I hope that helps with 13, and I believe 14 is similar. Let me come back to the homework now and show you. So yeah, 14 is going to be similar to that. Okay, now 15 starts Chebyshev's theorem. Chebyshev's theorem, okay. All of these 15 through 20 use Chebyshev's theorem. If you weren't aware, if you're watching this later than Sunday night, I'm going to post this video that you're watching now sometime Sunday. Okay. I posted yesterday, Saturday, 2 videos on Chebyshev's theorem. One is an explanation of number, I believe it was number 19. No, it was actually number 16. I posted a video of number 16. Okay, 16 is about the hardest problem on this homework. Okay, in my opinion. All right. I also posted an example problem that's not part of your homework that's very similar to some of the rest of these. All right. So I'd like you to try that before you come back and work on it. But there are 2 videos on Chebyshev's theorem to help you, which apply for 14 through 20. All right. So, sorry, not 14, 15 through 20. So I hope that this walkthrough of the homework for 3.2 is helpful to you. And I look forward to getting your questions and seeing you in my next video. Thank you guys. Talk to you soon. Bye for now.